Hello, everyone, and welcome to our new episode of the CTO Fellow podcast. And today we want to talk about one of our burning topics, which is platform as a service and why platform as a service is a good choice for small to medium sized companies and startups alike. For this, I invited today my good fellow Finn Christiansen. He worked already with a platform as a service solution we want to talk about today. And he worked much more with AWS. So he's basically a specialist for public clouds, and he implemented many systems already for many clients, worked as a freelancer. He's entrepreneur himself. So he's really proficient in what he's doing. And he got some insights lately regarding smaller companies and their challenges in the field. And we want to talk about those challenges today. What are the downsides? What are pros? What are cons for both of those things, like a larger infrastructure as a service provider like AWS is, and platform as a service, which is more integrated. So hello and welcome, Finn.
Yeah, thanks for having me.
Let's go straight into and maybe describe a little bit about yourself with your own words. What are you doing, where you're coming from, and what are your burning topics?
Yeah, I started my career as a physicist and specialized in X-ray physics. And there I developed a love for complex systems because if you see those giant machines with which you measure things, then you think, okay, it's made from steel, so it is very deterministic. There are no moving parts. Everything is like fixed and you can describe it as a perfect model. But if you get really in the fine details, you will see that the steel is weak, it bends, and so on. And it's not very deterministic. So you have to treat it more like this living thing. And I really like this stuff, but I think physics was a little bit slow. So I moved to complex cloud systems, and I think they are the same phenomena. For example, you would say, okay, the AWS documentation says that the system behaves in such a way. And oftentimes this is true. But if you say, well, let's set something, reset it over and over again, you suddenly see that it behaved the same as this complex physics machines. So it is not deterministic, and you have to treat it also more like this living thing. And I think this is very challenging, but also very interesting. I'm basically dealing with complex systems in the cloud. I try to make them simple so they are not complex systems anymore.
So thank you very much. That was a very interesting comparison between physics and modern cloud technologies and approaches. So we want to talk about, especially about the cloud. So infrastructure as a service in AWS. Please describe with your own words what you've already done there for clients and for other companies.
Yeah, and so basically, if you have an on-premise system that's not in the cloud, I have set up best practice cloud setups and migrated the system into the cloud. And when I'm doing this, I always try to make it cloud native. I don't think it's a good approach to just leave it as it is and put it into the cloud, because oftentimes then people complain and say, well, the cloud is not very good. It was better before. And oftentimes the reason for this is that if you use the cloud wrong, it's more expensive, it's more annoying, perhaps it's even more insecure. Also, I optimize cloud setups for my clients. So is it too expensive? Is it too complex? Or this is my most favorite part. Perhaps there's a better solution. For example, some clients are in AWS, but perhaps if they are a small to medium sized business, it's better to use another cloud vendor, for example, DigitalOcean, or a completely different thing. And I think also recently with all these AI tools, some people say, well, yeah, how can we sustain our business? But I think, as I described with this living thing analogy, that there's no one best solution, but it's a spectrum and you have to decide. So even if you could ask ChatGPT what is the best solution, it might come up with the best guess, but I don't think this is the way it works.
So you mentioned DigitalOcean. I think this is one of the topics today for the comparison, especially when it comes to the complicated nature of the public clouds, because they come from let's say, a different origin than the small to medium-sized businesses might have as a requirement, or targeted qualities. So those clouds are definitely made for enterprise level solutions. This is actually my own experience with that. It always felt a little bit overpowered for the requirements we had in the small to medium sized area where we need to create solutions for our clients and partners. Do you see it the same way? You are an AWS specialist. I'm not, so I'm just a user there. Would you say that AWS is too complicated for small businesses, or do you think it's just a lack of experience in using that? What would you say there?
I don't want to say it's too complicated, but I think a lot of benefits that you can use or you can have when using AWS, I don't think small to medium-sized businesses need them, but for larger or enterprise corporations, they are necessary. And if you like, we can talk about a containerized application. And I don't think we have to discuss everything, but perhaps we can use 3 simple points. And I can tell you what is very complicated, why AWS uses these mechanisms, and also why smaller companies shouldn't use them.
Okay, let's go.
Okay, we have this Node.js application, and you have your Docker container, and you just want to run it. So first you have to store the image somewhere. So there's this thing called Elastic Container Registry, ECR, in AWS. And AWS has this complex, I don't want to say complicated, but sometimes you need it, but this complex permission management. It's called IAM, Identity and Access Management. And basically, for every resource, there are like 3 questions. Who can do what with what? And for example, if you have this ECR registry, and you can say, okay, who? You have to say which entity in the cloud can do what with this resource. For example, the service that is running your application is the Elastic Container Service. And so the Elastic Container Service can do what? For example, download the image and on which exact ECR registry or repository. Registry is the whole thing, and the repository is for one Docker image. So if you just want to run this Docker image, you have to say, well, if I want to push it from my CI pipeline, I have to create a user for my CI pipeline. And this CI pipeline user can push the image to the repository. So I have to say this one can only push the image. The problem is if you want to delete the image or retag it or some different action in the future, then you have to fiddle around with the permissions again. So, and I think there are like 20 different actions or API calls on the Elastic Container Registry. So you have to exactly say what you have to use. And then your image is in the repository. Then you have to say, okay, let's run it on the Elastic Container Service. The Elastic Container Service has 2 permission entities, so to say. One role that does everything in preparation before running the service, and one role that is used on runtime. So the first role has to have permissions to download the image and put it in the Elastic Container Service. But if you follow best practices, then this role shouldn't have the rule to push the image because it's not necessary. Once you have the image in the Elastic Container Service, there's this other role, and this other role has to have the permissions to write to the logs and so on. And I don't want to waste time and describe it any more in depth, but perhaps you can see now that it's really complex. So, and if you say, for example, you are this huge enterprise and you have hundreds of images, and if you break one image, for example, if you push an image there, that's incorrect, and it breaks something somewhere else, then it's very important that you can only push to the one repository. But if you're a team of like 5 people, then it really doesn't matter. And it's so complicated.
Yeah, it's basically an overhead for, let's say, you shoot birds with cannons, right? And it is basically, when I see the applications we build in the past or build at the moment, they don't have those requirements. So it's like mostly it's just a two pizza team working on that project, or maybe another two pizza team is working on several projects. Then you don't want to have this complex permission systems in each of those projects, because you will basically run into problems like a minefield. And I think this doesn't really provide any benefits, at least in my opinion. So you need to simplify that in order to get a flow, because this is what really matters when it comes to small to medium sized businesses and startups. You need to create the value and not fiddle around, as you said, with permissions. So yeah, good example, actually. You want to have another example?
And let me give you another example for the problem with infrastructure as a service. So if you say my requirement is just to run this Docker container, then you want the service to be accessible from the internet. You want to put an URL in front of it. Traffic should go to this Docker image. And you want the logs to be sent to some log management system, for example, Datadog. And yeah, you like the service to be able to connect to a database. You have this cool idea, this cool project. You just want to develop something. But the problem is, I think those requirements are really simple. But if you want to do it in AWS, it's more complicated because there is no single thing that fulfills all these requirements, because it's not really a platform, but it's infrastructure. So if we talk about this example, we have this Elastic Container Service. If it's configured correctly, as I stated before, then it runs your Docker image. But now you want to send traffic to the Docker container. You have to create something called a route 53 record, which is basically a DNS record. This record points to a load balancer, and the load balancer sends the traffic to the Elastic Container Service, but it can't do it directly. You need some additional thing, and it's called a target group. And so the target group is some entity of IP addresses. And what AWS does, it takes this Elastic Container services or tasks, puts them in this target group, and then the load balancer can send traffic to it. But if you want to update the service, not only the Elastic Container Service is involved, but also all the other parts. And sometimes you have to do things manually. So you have to manage the life cycle of this whole thing by yourself, either by manually clicking it. I would strongly disencourage you to do it, but you can use Terraform for it. But then it's complicated because with Terraform, you usually provision infrastructure. But in this case, you are managing the life cycle as well. Again, if you have this enterprise setup, you really have to fine-tune it and perhaps save 0.5% of some costs. But I think it's really annoying to manage the life cycle of a platform if you just want to run a Docker container.
Yeah, it sounds like the origin for the term of developer burnout when it comes to DevOps, where developers are responsible for ops as well. And on some point, when something you describe as a cloud engineer, as an ops person, you can handle this. But on a daily basis, as a developer, especially for the DevOps culture idea, it is quite hard to feel comfortable with that, because it is not your discipline. And there are a lot of things you need to understand in order to get it right, to get it flawlessly. So you say for enterprises, this is a great solution because you can be very, very picky about what you want to do, very detailed. You can fulfill basically every requirement. You probably have the resources to do that. You maybe have a platform team in-house, basically an operations team helping you setting this up and maintaining that for developed teams. But we have the other side, like the smaller to medium-sized businesses and the startups, and they are, from day one, overwhelmed with that. So this is what I saw out there, basically on a daily basis. Let's go then to the possible solution for small to medium-sized businesses, and which is the topic of today, platform as a service. Can you give us some example there? So what would be the alternative with an example for a small to medium-sized business?
Yeah, and my example is the DigitalOcean app platform, and it's basically fulfills the requirements I just said. So you want to run a Docker container, make it accessible from the public network, connect it to a database, and send the logs easily to a log provider. And additionally, ad platform can do more things such as serverless and so on, but I want to concentrate on the containerized approach.
Mhm.
An app platform is, I would compare it to a Docker Compose file. So if you are able to write and run a Docker Compose file on your local machine, then you can very easily run an app platform as well. And it works like this. You have this app platform and you say, well, you have to run this container and you have to run this tag. For example, DigitalOcean has its own container registry, DOCR, and you push the image there. And the app platform listens to pushes to this container registry. For example, if you say the Adrian service on tag latest, then the app platform sees this and starts to trigger the deployment. And the important point is that it is like a closed loop system, like a black box. You don't have to do anything. You are completely done once you push the image to the registry. Then everything is handled inside. And what happens is that it has this life cycle. So you can see pre jobs. So if there's a new deployment, all pre jobs are run. Then you have the definition of the service, and you can say which jobs should be run after the deployment. So you have this whole life cycle. And basically, if you have some invalidation operations or whatever, you can put it in this pre-job. Then you have your main service. And after, you can call some webhooks, send it to Slack or whatever. And additionally, regarding logs, usually, if you use Kubernetes or something like that, a container sends the log to the output, and you have to have some sidecar. And the sidecar collects the logs and pushes it to some log provider like Datadog. But to be honest, you don't want to deal with the sidecars. You just want to say, well, I want the logs to be sent to Datadog. I don't want to reinvent the wheel. And with the DigitalOcean app platform, you can just say, okay, send it to Datadog. Here's my API key, and then you are done. It's really simple.
You just need to have an intake for Datadog or Papertrail or something like that.
Yeah, I mean the endpoint are known, so you just have to provide your API key because it knows like Datadog HQ.eu is the endpoint, and then yeah, it just works.
Yeah, so we are a little biased here. So we are app platform users ourselves. We use it quite frequently and as a foundation for most of our client native apps. And so I know what you mean. And for us, it's quite interesting that you have this all-in-one package without being a magic cloud provider. So in my opinion, it's not a magic cloud because you have still enough control over your orchestration to manage everything from a Jamstack up to a microservice architecture. You can basically do everything. So of course, there are some things missing which you would like to have, like auto scaling, which should be implemented somewhere this year, I hope. I heard about that on the Cloud Expo. We talked about that. So this is an upcoming feature now, but at the moment it's not there. So you need to take care of scaling yourself. It's a little bit more basic, but let's be honest, most of the startups and small to medium-sized businesses doesn't really have the need for an autoscaler in first place. So they can handle that with scaling. When you compare pricing, then I think it's okay to not have scaling in the first place. But as you said, you have logging, you have even a CI/CD pipeline. So if you don't have an external pipeline, you can use the internal pipeline, which is not the very best solution for complex things. So when you have complex pipelines, it's not that good. So it's good for, let's say, simple Docker image creation things. Then you can, just let it handle by the DigitalOcean platform. But yes, our setup is, just to mention it here, is like we have GitHub Actions for CI/CD pipeline, Datadog as an external tool for logging, but everything else happens inside the app platform per project. And we have several projects we're working on since we are a SaaS provider, so individual SaaS. And this is quite an interesting thing because we have so many app platforms at the moment running. They are all running the same pattern. And we personally don't even use Terraform at the moment. So you use Terraform because you were used to it and you had. Maybe you can talk a little bit about how it is with Terraform and DigitalOcean. So we can do it without, but if you have more complex scenarios, you can, of course, go with Terraform. What is your experience with Terraform and the app platform?
Yeah, mixed feelings. So I have to say, although I earn most of my money by doing AWS consulting, I run all of my own services, such as my website, some tools, some self-hosted versions of ready-to-use software. I run it all in DigitalOcean, so I think this says a lot about the complexity and which is the best solution for smaller teams or individual persons. And yeah, you can use Terraform. It works fine, like 95% of the time, but it has some flaws. And to understand it better, you have to understand how Terraform works. You have this Terraform executable, and it knows everything about like some internal functions. For example, Terraform can join arrays together, and this is all handled by the core. But if you want to communicate with vendors, for example, AWS or DigitalOcean, you have to use a provider. And there are all API definitions. Because if you say, well, in Terraform, I want to have 2 resources and there's only one, Terraform will create one. But if you say you want to have 2 resources and there are 3, Terraform will remove one. But this is not the way it works under the hood, right? Under the hood, something has to be deleted or created. It's more like for you it is simple, but in the end the API calls there are the same, either creating or destroying, deleting things. So there's this thing called provider in Terraform, and the AWS provider is used by many people and companies. So there are a lot of pull requests. It's very stable and so on. But I think most of the people use DigitalOcean by the internal tooling, for example, app spec file, we can talk about it later, or clicking things, doing click ops. And so I think this provider is less developed. So it has more bugs, not all things are implemented. I think it's more like in the beginning. So, and perhaps it will stay there because most of the people won't use Terraform with DigitalOcean. And there's this small but important thing. If you run a Docker container, you want to give it secrets as environment variables. For example, the connection string to a database. And there's this quite intelligent mechanism in App Platform. You can say, well, this is a secret, so I can provide it to the platform. Then the platform encrypts it, and you can change it, but you cannot see the value. You can only override it. You cannot extract it. And Terraform works like this. It checks your definition, how you want it to be, and then the status quo of the platform, and then aligns them, changing things in the cloud. The problem with secrets is if you create it in Terraform and say this is a secret environment variable, then App Platform will change it to some encrypted version. And if you run it the next time with Terraform, everything runs again, and basically every time you do a minor thing with Terraform, all of your containers will rotate because the platform sees it as a change. And there are a few of these little things, but they are very annoying. And I think, yeah, the provider should be improved, or you should switch to another solution.
So you mentioned AppSpec. This is what we use. So, I mean, I need to describe it now. It's like you have a YAML file, which looks a little bit like a Docker Compose file or more a Docker stack file, like the Docker orchestrator version. And you define basically an entire app with all the services, with the ingress mapping, with the environment variables and all this kind of stuff. And you can manage it via API. So you have the CLI API, and you can manage it in the pipeline like GitHub Actions. So it's important to say that in that moment, you should pick either the AppSpec version or the ClickOps version. So you should not mix it. This is basically an official recommendation because there can be differences depending on the current version of that. So this is some of those corner cases. We met that on some point as well. But yes, so you have this app spec. You can update this app spec. You can say, okay, for this container, you take this Git tag now, and then the app will redeploy and rotate the containers and drives a rolling update for those new containers, which have then changed. So this works quite well. Of course, some downsides. So you don't have that much of a control. So you can define it, but you can, for example, not things like, for example, canary deployments or blue-green deployments. It is basically you have only rolling updates, which is, as I said before, we're talking about small to medium-sized businesses who are using this. So rolling updates should be enough. So if you need something else, you might take a look into another solution there. So it's basically, in my opinion, the app platform is what you need for a basic cloud native containerized application or serverless. So it supports both containers and serverless functions. So you can handle this. And I would recommend to use app specs. The app specs is the more mature way of doing that. You can start with ClickOps to get an idea what happens there. It works pretty well with having a good pipeline plus the app spec. Then you have infrastructure as code. Yeah, it's not like so nuanced and powerful like Terraform. So saving states, you need to do that by yourself. So for example, the good thing is DigitalOcean App Platform is saving the states which were working for you. So let's say the last healthy states, you can always roll back to them. You have some kind of history, but if you want to have a more detailed history about that, you need to build it basically in your pipeline for yourself. So like you would do that with Terraform. So is it something you have experience with as well?
I'm using it as well for like smaller project, and I worked so long with Terraform. It's like a natural way for me to do it. But what I often see is if I show it to clients who are not proficient in Terraform, it's sometimes too much. If you say you have this on-premise approach, or for example, a lot of smaller companies have an external operations service. For example, you say, I just want to run my containers, or I want to run virtual machines. Then some external company manages everything for you. And if you say, well, let's use app platform, let's use Terraform, and let's use Datadog and everything in once, then it can be complicated. So yeah, perhaps I would start new projects with AppSpec as well. And I think AppSpec is like the native way to do it. And I would always use the native way if I start with new things.
Native and recommended. Okay, thank you. I would quickly wrap it up what we've said so far. So we have a solution which is, capable of being run with Terraform, but we have built-in mechanisms as well, which works quite well. So we can be productive. We can run several applications, staging production environments on larger scale, on smaller scale without any problems. So we have a working solution which is viable for small to medium-sized requirements. We have logging, we have metrics. So metrics is a point as well. So when you need to, push metrics to some system like Datadog, you need to have kind of a large budget to do that. And this is a good thing. I just want to mention that you have that already built in. All basic metrics you need for each services. You would know, for example, the load of a Redis server, the CPU and all this kind of stuff. You have an alerting mechanism, and you can have an uptime measurement, which is quite interesting. So you have basically this whole package, which fits for small to medium-sized businesses. But there are downsides as well. So it's not the holy grail, it is not the magic cloud. It is not like the large infrastructure as a service from the public clouds. So it's something in between, which means that it has downsides. For example, when you get into more complex scenarios, I see problems there personally. So I think you see those problems as well, and you were already running in those problems. Can you say something about the downsides of platform as a service solution like the app platform?
Yeah, for example, there are some features in Kubernetes that are not supported by their platform. And obviously, if you would support all features, you would have Kubernetes. So I mentioned this life cycle, this pre-jobs that runs before a deployment is done, then the running of the container itself, and then the after job. And you can define multiple pre-jobs in this life cycle, but the app platform doesn't guarantee a sequential execution. So if you say, well, you have Kubernetes, then you have this lifecycle hooks and you can give them a weight. So they are in strict sequential order. For example, if you want to deploy your service and then you have to run job A, job B, job C, then run your service, and afterwards C, D, E, then you cannot do it in the app platform without hacking it. There are workarounds, but they get really complicated and also very expensive. And this is a downside, but then I would question, is it really necessary to do it this way? Because I think it's a chance you have like this best practice setup, and perhaps it's easier to simplify your setup instead of trying to get it work.
It's this phrase, don't fix development problems with ops. So as you mentioned, jobs, for example, in an infrastructure like deployment phase, which shall then, for example, migrate database things or something like that. This is the wrong place to do that. So you should, in my opinion, do that in the containers which are running anyway. So migration, it is a common standard already. So I think that was something we need to use in the past, especially when you have those larger legacy applications with a lot of things happening in between. Okay. But for modern cloud native applications, which were developed natively for the cloud, you shouldn't have those jobs. So basically, we never used one of them. And we are very happy with every microservice architecture there. So I would say you don't need them.
Definitely. And yeah, another downside, or I wouldn't say downside, but limitation is you can't use volumes.
Yeah.
So, for example, oftentimes you develop your own software, but sometimes you say, okay, I want to run this open source software inside my infrastructure. For example, if you want to use this content management system Strapi, then you can just use the official Docker image. I'm not sure if this is a good example because I don't know if Strapi uses volumes, but for the example, if you run it and it needs some persistent data and it's not like in a database or not in a S3 bucket, but it's a folder inside the Docker image, then you would use volumes in Kubernetes. And they are not supported in app platform. I think it's a good thing because I think you shouldn't use them. But if you say, I really, really, really have to use them, but then I would say, okay, then let's run all of your applications in app platform and have one Kubernetes cluster with one node or two nodes just for this, or use a Docker Swarm or virtual machine or another thing. And yeah, for all your self-developed applications, then you can use the app platform.
Mm-hmm. So that's actually a good point. So volumes in the very beginning, when we migrated into the cloud, we wanted to use our volumes. They weren't available. So we had basically a hard requirement to use S3 compatible spaces. So actually, this is the name of DigitalOcean for their S3 compatible solution. And yeah, we needed to rewrite things. So for example, in a dev environment, people are working with volumes, while in a production environment, you work with S3 buckets. So our backend developers there create handlers for this. So they basically adapt to the environment they are working and then storing data via another interface. It's quite interesting. So it works. So still not a downside, in my opinion, when it comes to modern cloud native things. So it shouldn't be a downside there. But of course, for legacy projects or more complicated projects within the cloud, it's probably something which makes this simple idea of app platform obsolete, because when you need to change or add something outside of the app platform to use it, you can then change to something more complex, which is then more infrastructure as a service. So in my opinion, app platform is only then an adequate solution when everything you need can be handled inside the app platform itself. So maybe, CI/CD pipeline, a little bit of logging there, that's okay. But everything essential when it comes to orchestration should happen inside there. For example, if you need something very specific for your proxy or for your load balancer, some special rules or something like that, which are not provided from scratch, then it might be a no-go to use the app platform because this part is very static. So you can do a lot, but not everything. So for example, when you need to federate for example, a legacy system and a cloud system, which we've done already, we basically set up an Nginx outside of the platform to have this, to make this possible. It is not a good idea to do this within a platform because you already have a controller in before that, which you cannot really control. And when you put an Nginx or something similar inside the app platform, you might have problems with some network traffic. So you cannot really take a look inside what happens there. The app platform is connected to Cloudflare, CDN network. So those things are not available to you. So those are the downsides, in my opinion. So you lack control, which is you need to be sure that your requirements and your qualities you need to target are fitting into this product package, which is, in my opinion, mostly the case, but not always. So you need to determine that, and that's totally fine. Would you agree with that?
Yeah, but I would use a little bit different wording. I would use not problems, but limitations. And you have these limitations, but I think they are a good thing. If you cannot use volumes, I mean, you shouldn't use volumes nowadays. So this is just a limitation, but it kind of forces you to use best practices. But then you have to think, okay, is it really the best solution? Because DigitalOcean has a database backup functionalities as well. And if you say you don't trust them or you don't fully trust them, perhaps you can use another approach. For example, having a backup service that pulls the data out of the database or some other things. So I would say it limits you. And by that, it saves you from fiddling around with hacky approaches.
Yeah. So actually, we weren't able to implement any worst practices there. So this is already something very, very well defined. But there are downsides. For example, you mentioned backups. There are built-in backups, but still for the S3 solution, there is no built-in backup yet. So you need to synchronize the data to an external storage in order to create your backups yourself. For all other services, managed services, there are built-in backups. So, you can basically restore in time. It's good to have the first layer of defense there. So when I need to wrap this up, I would say that DigitalOcean platform, for me, it's a good definition for platform as a service. You as a company take something which is working out of the box and is already covering most of your requirements, and the rest you can just easily integrate. So this is your platform. The platform is running basically on your local machine as well. For example, in this case, as a Docker Compose file, translate that into an app spec, and then you can basically have your development platform and your production platform. And this is the platform as a service idea without having a platform engineering team. Those were the pros, but there are cons as well. As soon as it gets complicated or you have more specific requirements or other things which goes beyond the standard cloud native features, you will run into problems very early on. And this is the point where you should understand before you pick a solution, what are the limitations? Let's stick with this word. What are the limitations which you will face, and then you can make a decision. So what I can say is we can basically nearly run every of our applications there. So we have some outside, of course, but the majority, especially the newer ones, which are built already cloud native, those have no problems running there because we created them like they can run there. So it's no problem there. For example, when we go for pub subsystems, MQ, we have that built into the containers together with Redis because, DigitalOcean doesn't have something like SQS from AWS. So you need to do that yourself. So this might be a downside as well. Of course, you can use AWS as an external service, but then we come to the point again, if you shouldn't go directly to AWS and do your solution there. And you need to determine, this is a decision-making process. So does it fit to you or does it not fit to you? In my opinion, it's a good fit for many companies, but not for all. Would you go with that?
I would totally agree. And at the one thing you said that you have to say, okay, does it fit me? Am I using only the cloud native approach? Or do I have other special requirements? And then I have to use something like AWS. Before going to AWS directly, you should ask yourself, is it really necessary? And perhaps ask a consultant, ask other people, really question this because it can be a really, really expensive decision.
Yeah, That's always a good idea to ask someone, especially when it comes to comparing products. Maybe ask several people about that. So this is just my personal opinion that you should do that. Understand first. So I write a lot about understanding and learning. So thank you for that. So when people want to reach out to you in order to get help with their AWS or DigitalOcean services, how can they reach you?
Yeah, I think there are two easy ways. First is just visit my website, finnchristiansen.com. It's just one, or just reach out to me on LinkedIn. If you search me, then I think it's easy to find me.
Okay, great. So thank you very much for attending today. So we have our 20 minutes full, just 30 minutes over. So I hope everyone took something from that. And if you have any questions, there will be clips on LinkedIn. If you want to talk, if you want to discuss about that, we can help you there and give you some hints if this solution or other solutions, other similar platform as a service solutions might be the fit for your company. So have a nice day. Thank you very much, Finn, for attending. And yes, goodbye.
Goodbye.